When you think of a volcano, chances are the first thing that comes to mind is a cone-shaped mountain with lava and ash spewing out the top. This makes sense, as volcanoes like these do exist, and they form an iconic image in one's mind. But what if I told you that this is far from the only type of volcano in existence? As it turns out, volcanoes come in several different types and flavors, and each one not only looks extremely different, but how they erupt varies as well, and this has huge implications for the volcano itself and the surrounding landscape. Now, before we get into mountains of fire, I'd appreciate the video, subscribe to your channel, and hit the notification bell to stay tuned for future content. Okay, so let's start with that classic cone-shaped volcano. These volcanoes are scientifically known as stratovolcanoes or composite volcanoes, named due to their layered internal structure. These volcanoes form when two plates crash into each other at subduction zones, where continental crust is folded on top of each other to form a mountain range. Usually when this happens, this merely creates a chain of mountains that have little to no volcanic activity, such as the Himalayas in Asia. However, in some specific circumstances, magma is able to rise through the crust and get a lot closer to the surface than it can otherwise, creating magma chambers that will occasionally break through to the surface and create a volcano. Many of the most notable volcanoes are stratovolcanoes, like Mount St. Helens in Washington or Mount Fuji in Japan. Since these picturesque volcanoes are still, in fact, volcanoes, they can pose a real threat to the surrounding terrain when they do erupt. One danger that's usually specific to stratovolcanoes is what's known as a lahar. You see, many of these volcanoes are extremely tall mountains, oftentimes tall enough for significant amounts of snow and ice to accumulate at the summit. And these glaciers are essentially a ticking time bomb if the volcano is active, because if it erupts, all of that snow and ice will melt pretty much instantly. The snow melt can then combine with the lava and ash from the eruption itself, as well as any extra debris caused by the eruption, to create an absolutely horrid sludge. This sludge tends to race down the steep slopes of the stratovolcano, eventually funneling into a river valley where it can go on to decimate populated areas. A particularly devastating example of this happened in Colombia in 1985, when a small eruption on the volcano Nevado del Ruiz triggered a lahar that would destroy a nearby town, killing an estimated 20,000 people and making the disaster among the worst volcanic disasters in recorded history. It just goes to show that you don't necessarily need a huge eruption to cause major devastation in nearby areas. Okay, but what about a type of volcano that isn't a perfect cone, but is rather a behemoth with miles upon miles of gentle slopes leading to a much more unassuming summit? This type of volcano is known as a shield volcano, since those gentle slopes leading to an elevated area in the very center is similar to what an actual shield is like. While stratovolcanoes are known for their explosive eruptions, shield volcanoes instead periodically ooze lava from either their summit or a potential vent lower down the mountain, which works to slowly build up the mountain to astronomical proportions over hundreds of thousands of years. One side effect of this is that they are often erupting almost continuously or very frequently, as opposed to stratovolcanoes, which usually go years, decades, or even centuries without emitting a single drop of lava. Instead of plate tectonics, shield volcanoes form through what's known as a hotspot, which is an enormous plume of magma that extends to Earth's core mantle boundary, 2,000 miles below the surface. This provides the volcano with a near constant source of magma, which is part of what allows them to erupt as much as they do. The most notable example of a shield volcano on Earth are the ones on Hawaii's Big Island, mainly Mauna Loa and Kilauea. The latter erupted continuously for a staggering 35 years, between 1983 and 2018, and has continued to erupt frequently since. However, because shield volcanoes don't need plate tectonics to exist, they can be found on other planets. This includes Olympus Mons on Mars, which is not only the tallest mountain in the solar system, rising to 3 times the height of Mount Everest, but its nature as a shield volcano means it could grow substantially outward as well, with its base having a diameter comparable to the US state of Missouri. Okay, to finish off the video, let's look at something a little different: underwater volcanoes. A volcano is defined as any opening in the crust where stuff like magma and ash can escape, and there is nothing inherently about oceans that can prevent this. Underwater volcanoes can form through both plate tectonics and hotspots, and in fact, there is an undersea volcano off the southeastern coast of the Big Island that is projected to breach the surface and create a new entry in the Hawaiian island chain in about 100,000 years. Though the volcanoes themselves are the same, there is still the fact that there is an entire ocean's worth of water above them, so the eruptions themselves look dramatically different. For instance, lava will cool and solidify much faster underwater than on land, eventually leading to lava flowing underneath a solid surface, something known as pillow lava. You would expect that the presence of lava would cause water to boil when the eruption happens, and for volcanoes closer to the surface, that will happen. However, deeper than about 7,000 feet or 2,200 meters below the surface, the pressure of the ocean is so high that water won't boil even when exposed to something as hot as molten rock. One of the most notable underwater volcano eruptions was at the, say it with me, Hunga Tonga Hunga Hapai underwater volcano near the Pacific island nation of Tonga. Yeah, I definitely butchered that pronunciation. Anyway, this volcano blew its lid off in January of 2022, producing an explosion that was not only the biggest underwater explosion in recent memory, but the biggest volcanic eruption period since the Pinatubo eruption in 1991. This explosion was so huge, it triggered tsunamis that were felt all around the Pacific Ocean, from Japan all the way to Peru. Normally, when a massive volcanic eruption happens, it produces enough ash in the atmosphere to temporarily cool the planet, as the Pinatubo eruption did 30 years earlier. However, since the Hunga Tonga eruption was underwater, it vaporized a colossal amount of water in addition to the ash it produced. And since water vapor is a greenhouse gas, it is predicted to have the inverse effect of warming the planet instead, likely increasing the chances of Earth exceeding critical climate goals within the next few years. One upside of underwater volcanoes as a whole is that people generally don't live underwater, so there isn't a direct risk to human life as volcanoes on land do. However, the explosions and subsequent tsunamis can still pose a hazard to people on boats nearby, as well as populated islands that may be near the volcano. So, moral of the story is, regardless of what the volcano is, if it looks like it's rumbling, it's probably good to stay away from it. And that's all I have to say about volcanoes. As always, I'd appreciate if you like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Thanks and have a great day.